Hello everyone. In this video, we will solve oblique triangles. And by definition, oblique triangles are those triangles that have no right angles. So it could be an acute triangle or an obtuse triangle. So we can actually solve oblique triangles by the law of sines, which is already given in this illustration, that by standard notation, given angle A, B, and C, and their opposite sides, which are side A, side B, and then side C, we'll be able to create the relationship of the ratios of the opposite side and the angle, which is side A over sine of angle A is equal to side B over sine of angle B, and then we have side C over sine of angle C. So that is by the law of sines. We can solve oblique triangles if we are given first two angles and any side. It could be AAS or ASA. So that could be an angle, and then a side. Or it could be an angle, a side, and then an angle. And then we also have, in the second case, we are given two sides and an angle. So it could be SSA if we are given two sides, which is SS and then an angle. Let's say, for example, we want to show from this illustration that if B is equal to 24 feet and C is 103.2 degrees together with an angle B, which is 28.8 degrees. Okay, so given that angle C measures 103.2 and then angle B measures 28.8 degrees. So with the sum of this will be equal to 132.0 degrees. Now, as we all know, if we are going to add angle A, B, and C, that will be equal to 180 degrees. Therefore, if we are already given angle B and angle C, we can actually subtract 132 from 180 so that we'll be able to get the value of angle A. So right here, angle A will measure 48 degrees. Okay, so in that case, we'll be able to solve for the value of angle A, which is 48 degrees. Now, since we are given angle B, which is opposite of side B, which is given as 24 feet, then we can actually solve for A and C by the following law of sines. So let us solve first for A. Since we are given 28.8 degrees on angle B, we can actually substitute that on this equation. So side B is 24 feet and then angle B is 28.8 degrees. That is sine 28.8 degrees. Now, if we are trying to solve for A, side A, which is opposite of angle A, therefore, we'll be able to take this ratio A over sine A. So A is unknown, so we'll retain it as letter A, and then we'll write down sine of angle A is given as 48 degrees as we have solved a while ago. So this will be sine 48 degrees. Now, by isolation of A, if we are going to multiply both sides by sine 48 degrees, we'll be able to show that A will be equal to 24 over sine 28.8 degrees times sine 48 degrees. So from this point of our solution, we need a calculator to solve for this. So let us show that by the use of a calculator. 24 over sine 28.8 degrees. So that will be a fraction. 24 over sine 28.8 degrees times the given sine of angle A, which is 48 degrees. Then we'll be able to identify that the value of side A is 37.021981, etc. So we'll just round it off to the nearest hundreds. So the value of A is approximately equal to 37.02. A will now be 37.02 feet. Okay, so let us show that. So A is equal to 37.02 feet. Now, if we want to solve for side C, therefore we need to use another pair of ratios from the law of sines. So let's take for example B over sine B and then C over sine C. Since we want to solve for side C right here, we will be using those pair of ratios. Okay, so let us show that by the use of a solution. So, okay, so we know that B is 24 and angle B is 28.8 degrees. So that will be sine 28.8 degrees is equal to, since we are solving for C, we'll retain that as letter C. And then angle C is 103.2 degrees. So let us check. That is 103.2 degrees and 28.8 degrees together with B, which is 24. Since we already have substituted the given values, let us now solve for C. So multiplying both sides by sine 103.2 degrees, we'll be able to isolate C, and then our equation will be 24 over sine 28.8 degrees times sine 103.2 degrees. From this point of our solution, we need a calculator for that. So sine 103.2 times the ratio of 24 over sine 28.8. So we'll be able to solve that the value for C is 48.50. Rounded off to the nearest hundreds, C will be approximately equal to 48.50 feet. Okay, so right here, C is approximately equal to 48.50 feet. Okay, so from here, we were able to solve an oblique triangle with the first case, which is we are given an angle, and then a side. Thank you so much for watching and see you on the next videos.